After its launch, Cassini's next major challenge was to gain the additional momentum required to make the billion-mile-plus journey from Earth to the Saturnian system. To do this, Cassini needed help, a boost, and several at that. Through a series of complex maneuvers engineers call a gravity assist, Cassini made close flybys of several other planets, using their gravity like a celestial slingshot to gain enough speed to make it all the way out to Saturn. And in 2004, Cassini was close enough to its destination to send back this image. Although still over 43 million miles from Saturn, the detail of both the rings and the atmosphere was breathtaking. In July of 2004, Cassini finally entered Saturn's space and began its 4-year prime mission. Its first order of business was Phoebe, one of Saturn's 53 named moons. Cassini's powerful cameras revealed areas where landslides have tumbled down steep crater walls, uncovering a brighter composition below the surface. Scientists speculate that the relatively dark surface may just be a cloak covering a much brighter, icy object underneath, an object that could have started its life much farther from the Sun, but was captured into orbit by the immense gravity of Saturn. 19 days after flying past Phoebe, Cassini faced another critical challenge. It too needed to be captured by the ringed planet's gravity. Engineers call this maneuver an orbit insertion, and to perform it successfully, Cassini had to fire its main engines with intense precision, or risk shooting past the planet and being lost forever in deep space. After successfully accomplishing the orbit insertion, Cassini was now prepared to begin its main mission in earnest. In 1610, the father of modern astronomy, Galileo Galilei, peered through his primitive telescope at Saturn and saw something he could not explain. At a loss for words, he made sketches showing two strange objects on either side of the planet. He surmised that perhaps they were two large moons orbiting very close to the planet. 45 years later, another astronomer, Christian Huygens, used a more powerful telescope to study Saturn. And it was he who suggested that these strange objects were not moons at all, but enormous rings encircling the planet. We know today from Cassini's detailed views that what once appeared to be 3 distinct rings is actually a complex system of ever-changing rings and ringlets, each composed of millions upon millions of ring particles. Made mostly of frozen water ice, particles range in size from chunks as large as a house to grains as tiny as a fine powder. All of them race around Saturn in their own orbits at close to 50,000 miles per hour. The diameter of Saturn's ring system is enormous, nearly 200,000 miles across. That is almost the same distance as from the Earth to our moon. And yet, for this incredibly enormous span, the rings are barely 30 feet thick, or about as tall as a modern 2-story building. In 2009, Cassini captured images of Saturn in an equinox. An equinox is when a planet is in a point in both space and time, so that its northern and southern hemispheres are lit equally by the sun. This provided a rare viewing opportunity for scientists. They had predicted that with the rings lit edge-on this way, when viewed from above or below, any distortions in their equilibrium should stick out and cast shadows. They were right. Cassini found deviations in ring composition that extended above and below the rest of the rings by as much as 2 miles. In some cases, the result of gravitational influence from tiny moons like Daphnis. In others, groups of ring particles bunch together and propel themselves into space. Cassini found that the rings of Saturn are a constantly shifting and changing dance of activity. The larger particles in moons exert gravitational forces on smaller particles, tugging and shaping the rings, causing their edges to scallop in some places, and to kink or braid in others. This amazing ballet of cosmic particles in moons, when viewed up close, confirms in yet another way the wonder of this majestic planet. The second largest planet in our solar system, Saturn is one of 4 gas giants that make up the outer planets. The largest is Jupiter, recognized for its collage of color and swirling bands of clouds. By contrast, Saturn has always appeared somewhat more subdued, but Cassini's close scrutiny of its surface revealed that it too is a wildly active mosaic of spots and swirls, evidence of huge, powerful storms, some as large as the Earth itself, and undulating ribbons reveal powerful jet streams that race across Saturn at speeds of more than 1,000 miles per hour. One area of Saturn seems especially active, with huge and violent storms that rage non-stop, sometimes for 9 months at a time, before fading away, only to return again and again, and always along the same latitude. And no one knows why. Thunderstorms on Earth can tower 6 to 9 miles into the atmosphere. In Saturn's Storm Alley, clouds rise more than 60 miles high, unleashing super bolts of lightning beyond anything we experience on Earth. And the rain on Saturn is a mixture of ammonia and other exotic chemicals present in the atmosphere. Even at the poles, Cassini found astonishing weather activity, unlike anything we find near the poles of Earth. At the South Pole, to everyone's surprise, is what, by all intents and purposes, looks like a gigantic hurricane. Its eye wall alone measures a staggering 600 miles in diameter, and rises more than 40 miles into the sky. In all, this hurricane is more than twice the size of the entire United States. What powers this raging monster is still a mystery. However, what Cassini saw at the North Polar region is even more perplexing. Here, Cassini's infrared imaging instrument captured an atmospheric anomaly as bizarre as anything seen in the universe. A 6-sided, nearly perfect hexagonal cloud feature that sits atop the planet. At roughly 15,000 miles wide, nearly 4 Earths could fit inside it. First glimpsed in 1980 by the Voyager spacecraft on their grand tour of the solar system, we know this mesmerizing oddity has persisted for at least 30 years, and likely much longer. Like the Earth and many other large celestial bodies, Saturn has a magnetosphere, a region that surrounds a planet or object influenced by its magnetic field. Here, charged particles collide with atoms and are directed by the magnetic fields down into the planet's atmosphere. The result are the natural and beautiful light displays that we call auroras. On Earth, auroras create luminous curtains of light that may stretch 20 or more miles into the sky. Because of Saturn's immensity, though, and its significantly larger magnetosphere, these brilliant displays can stretch more than 750 miles into the Saturnian sky. Something else Saturn has in common with Earth are seasons. But Saturn takes nearly 30 Earth years to orbit the Sun just once, so each of its seasons lasts roughly 7 years. This means that Cassini has only been at Saturn long enough to observe just a part of a Saturnian summer in the southern hemisphere and a winter in the north. But as the seasons now begin to change, shifting solar illumination and surface temperatures have resulted in dramatic new weather phenomena. including this enormous megastorm that is now raging around Saturn's northern mid-latitudes. First detected in December of 2010, this storm has now grown to an unprecedented size. It now covers approximately 2 billion square miles of the planet's surface, making it more than 500 times larger than any storm previously observed on Saturn. But for all of the incomparable beauty and spectacle of the planet itself, some of the most interesting discoveries of all were found among Saturn's myriad moons. Saturn has 62 confirmed moons, the most of any planet in the solar system. Most are small, at less than 31 miles across. But some of the larger moons are as intriguing as anything in the solar system. This is Mimas, recognizable for its massive crater that spans more than 80 miles in diameter, a remnant of an impact so violent it nearly split Mimas in two. Iapetus is Saturn's third largest moon, and seems to have almost a split personality, with one side a soft white in color, like a newly fallen snow, and the other side a dark and tarnished surface. And running along the equator of this moon is a mountain ridge more than 800 miles long, 12 miles wide, and reaching more than 42,000 feet high. That's taller than even the Himalayas on Earth. The bizarre-looking Hyperion was the first non-spherical moon to be found. Its irregular shape, its chaotic rotation, and its bizarre sponge-like appearance remain unexplained. But among the smaller icy moons of Saturn, none has generated more excitement and fascination than Enceladus. Smaller even than our own moon, it is still one of the brightest objects in the solar system, its frozen surface reflecting nearly 100% of the sunlight that hits it. So it was quite surprising when Cassini detected a hot zone along Enceladus' south pole. Closer inspection revealed a very active surface geology, with cracks and fissures continually forming and reforming in the icy crust. Cassini made several very close flybys of Enceladus, and scientists were astounded by the discovery of huge plumes of water vapor and ice crystals continuously venting out into space from this southern hot zone. It soon became clear that these geysers, dubbed Cold Faithful, were actually the material source for Saturn's immense yet diffuse E-ring. But even more significantly, they suggest that a liquid ocean, warmed by volcanic activity, may exist beneath the frozen surface of Enceladus, making it one of the most promising candidates for harboring microbial life in our solar system. But even as surprising as Enceladus has proven to be, others would argue that the most scientifically important of Saturn's many moons is Titan. The second largest moon in the solar system, and larger even than the planet Mercury. If Titan were to break free of Saturn's gravity, we would call it a planet. Titan has been intriguing scientists and astronomers for centuries, but its extremely dense and hazy atmosphere obscures its surface, making it nearly impossible to study from a distance. Cassini changed that, because across the miles and the years, Cassini carried a passenger, the Huygens probe. Named after the man who discovered Titan more than 450 years before, this little probe would achieve very big things. As humankind's first landing on a body in the outer solar system, the probe parachuted through Titan's murky skies, taking atmospheric measurements and a revealing series of surface pictures along its descent. Between the Huygens probe and Cassini's own radar imaging, the veil has been pulled back from Titan, exposing a landscape that has enthralled scientists with its stunningly Earth-like qualities. Lakes, rivers, shorelines, mountains, and dunes. In fact, Titan's surface appears more Earth-like than any other body in the solar system. Despite sub-freezing temperatures and an atmosphere made mostly of nitrogen and methane. With average temperatures of minus 185 degrees Celsius, water would freeze as hard as rock on Titan. But methane becomes liquid at those extremes. Experts believe it is a methane rain that falls on Titan, carving rivers and forming lakes of liquid natural gas. With its active surface erosion, and as the only other object known in the solar system to support stable bodies of surface liquid, Titan is perhaps the best analog of a primordial Earth that we can study. And the more we learn about Titan, the more we may come to understand our own planet's origins and evolution. The Cassini mission has been a spectacular success, expanding our understanding of Saturn, its enchanting rings, and its mysterious moons. Built on the legacies of missions past, Cassini's success represents the hopes and dreams, the struggles and triumphs of the engineers, scientists, and hundreds of dedicated professionals that have contributed to its design, its construction, and its operation. The spacecraft and its team continue their exploration of the Saturnian system, and more fascinating discoveries surely await. In time, however, Cassini will exhaust its remaining fuel. As that time approaches, mission navigators have devised a plan that they hope will thread Cassini into the small space between the innermost ring and the planet itself. Here, Cassini will observe Saturn in unrivaled detail for 22 orbits, before gravity finally has its way and draws the spacecraft down into the cloud tops, bringing to a close one of the most remarkable and successful space and science adventures of all time.